Good afternoon, everyone. Today, I'm going to show you a successful story where materials research can be directly contribute to energy conversion applications that can help to solve today's renewable energy problems. As an introduction, let's start with the most basic phenomena, the thermoelectric feedback effect. So here I have a piece of conductor. Electrons are uniformly disturbing it. When we apply a thermal gradient, those thermally excited electrons on the hot side will diffuse to the low temperature, which is the cold side, and then this will cause a potential difference. Now, when we have holes instead of electrons as the charge carrier, we will observe a similar phenomenon with an opposite current direction, and the potential difference divided by the temperature difference is the value of the Seebeck coefficient. With this in mind, now by using thermoelectric materials, thermoelectric devices can be applied for different purposes. For instance, when we apply a potential difference between the two sides of the device, it will absorb heat in one side and release heat in the other side. Applications are like thermoelectric cooler, warmer, or refrigerators. Well, conversely, when we apply a temperature gradient between the two sides of the device, a current will be produced, which can be used as a power generator. For instance, here I have a thermoelectric watch. It can convert the difference between the temperature of your skin and the temperature outside to electricity, which means you can run without a battery. Such power generation applications are even more valuable in deep space studies since there are not many choices to be used as a power supply. Well, here in the United States, one of the most important applications for thermoelectric devices is the application for automobiles. For instance, here, according to the annual report from General Motors, around 40% of the energy combustion is wasted by the exhaust gas. So by applying a thermoelectric device as a power generator, this part of the waste energy can be collected and converted into electricity to put it back into the car to increase the fuel efficiency. In addition to that, if we look at these figures here, which is the 3D active cooling system, by using a thermoelectric device instead of a compressor, it can actually cool passengers more directly and more efficiently without the need to cool the whole space inside the vehicle, and this will increase the overall vehicle efficiency as well. Now, speaking of the efficiency of thermoelectric devices is closely related to this equation, which is the dimensionless thermoelectric figure of merit ZT. It is composed by the Seebeck coefficient, the electrical conductivity, and the thermal conductivity. The focus of my research is to investigate materials that has the potential can balance these parameters very well and give us the best ZT value. So one particular interesting material system is the so-called 1-20 family of compound. Looking at the periodic table, we have a very large playground to work with, right? So in fact, in our group, we were able to synthesize many different 1-20 materials from this family. So I want to point out this one here, which show exceptional promising thermoelectric properties due to its unique features. So these 1-20 materials, they have this cubic crystal structure. One unique feature I want to point out is the Frank-Casper polyhedron here, which I have a 3D printed cage. So the black cage frame represents the zinc atoms, and inside there is this ytterbium atom. During the heat transport, the ytterbium atom is going to rattle about inside the cage, and such behavior will result in a low lattice thermal conductivity, which is very important in terms of having a large ZT value. Together with the large Seebeck coefficient at low temperatures, as well as the high electrical conductivity, these materials show promising thermoelectric properties, and then it's very promising upon a stage to design the next generation of energy conversion applications. Thank you very much for your attention.